Right? More practice factoring. Right? You know, if we were in the middle of a verification problem and we had secant squared minus 1, I doubt we'd be factoring it. We'd probably be substituting for tan squared. But in terms of factoring, what kind of factoring could we do on secant squared minus 1? It's a difference of squares. So how would it factor? Secant theta minus 1, secant theta plus 1. Where? 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 Here? Here? To do difference of squares. Why? Because we recognize that we had a better substitution to make. I mean, you could try it, but that would have been a mess. I think, you know, I'm not sure where you ended up with that. Since you had the cosine squared and you knew you had a sine x, you can't make a substitution for sine x. You can really only make a substitution for sine squared or cosine squared. And since you had the cosine squared, we substituted to make it all sine. But could you have done a difference of squares there? Sure. That would have been cosine plus 1, cosine minus 1. But it doesn't mean you're always going to do that. It's not always the right path. All right. This factoring here, I mean, this is a quadratic. Think of it like 4x squared plus x minus 3. I mean, that is a quadratic that we can factor. And this will factor exactly the same way. Right? This is a factoring because the a is not 1. You've got to go 4 times negative 3 is negative 12. What are the factors of negative 12 that add up to 1? Casey? 4 and negative 3, right? So negative 3 times 4. So we're going to do the same thing. We use those to split up the middle term. 4 tan squared theta minus 3 tan theta plus 4 tan theta minus 3. Right, we split up this middle term. And then we group the first two terms, and we group the last two terms, and we factor each set of parentheses. Right, in the first set of parentheses, what's the greatest common factor? Tan theta. So you factor out a tan theta, and we got 4 tan theta minus 3. And the second set of parentheses, no common factor. 4 tan theta minus 3. And then, as always, in this kind of factoring, at this step, what's in parentheses should be the same. Right? It's two terms. Each have a factor of 4 tan theta minus 3. So the last step is 4 tan theta minus 3 times tan theta plus 1. If you prefer, you could have just factored that, and then at the last step, substitute x equals tan theta. Right? If you didn't want to work with tan theta everywhere, just factor that, and then when you get to the end, everywhere you have an x, put a tan theta.